Hello and welcome to this lecture on fundamentals of electric drives. In the last lecture, we were discussing about the motoring and braking operation with chopper fed control. Now, we will see how we can combine this motoring and braking with a single chopper. So, individually the chopper can operate either in first quadrant or in second quadrant. Now, we can combine these two chopper to have both motoring and braking. So, we will be discussing about two quadrant chopper in today's lecture. So, we have what we are trying to do here, we are trying to do both motoring and braking by having a single chopper. We have two classification. We have a type A chopper, that is two quadrant chopper. So, type A two quadrant chopper look like this. We combine the choppers for motoring and braking. These are the feedback diodes here. And we have the armature, which is represented by the resistance, inductance and the back EMF. So, we call the transistor here, this is the input side, we have the voltage here, that is supply voltage V. So, this is T1, the transistor T1, the diode D1, the transistor T2 and the diode D2. This is the armature resistance, armature inductance, and we have the back EMF, that is E. This represents the armature of the DC machine as before. So, the current here is into the armature and the voltage is across this armature, that is VA, armature voltage. The supply voltage is V, that is the DC supply voltage. Now, this is a type A two quadrant chopper. So, we see that VA, armature voltage, is equal to V either if T1 or D2 is on. Now, if we have either this switch on or the diode on, the input voltage is same as the output voltage, that is VA is capital V, and that is equal to 0 if T2 or D1 is on. If we switch on this diode or the transistor this, when either one of these devices is conducting, there is a freewheeling path here like this, or there is a energy storage interval. So, the voltage VA is short circuited. So, VA is equal to 0. So, the voltage VA is always positive here. So, VA is always positive. So, which means for this VA is always greater or equal to 0. Now, we have the current possibility IA, armature current. Now, we have the possibility here, the armature current can be positive or can be negative. Armature current can be positive if the transistor T1 is on or D1 is on. So, we have two possibilities, either we have the transistor T1 on or D1 on. In that case, either we have the current which is flowing from the source like this, that is a positive current, or if D1 is on, the current is freewheeling like this, then that is also a positive current. So, we can say that IA is equal to, or IA is positive if T1 or D1 is on. Can we have negative current? Yes, in this case we can have negative current. The current can be negative if either T2 is on or D2 is on. If T2 or D2 is on. So, voltage remaining positive, current is reversible. So, it means IA is reversible. So, if we plot this operation of this two quadrant type A chopper, say for example, if we are plotting either, I mean let us say in VI plane, the armature voltage is in the y axis and the armature current is in the x axis. So, we have xy plane here and this is the armature voltage and this is the armature current. So, the voltage is always positive, this can be 0, but this is mostly positive, but the current can be negative. So, this chopper operates in these two quadrant. So, it is a two quadrant chopper. Now, let us see the voltage and the current waveforms. Now, if we plot the voltage and current waveforms here, let us say we plot the armature voltage. It is either V or 0. So, this is the time t on, let us say, and this is the time t off, and this is the total time t. Now, what we do here, when I say t on, we mean the transistor T1 is on and the transistor T1 and T2 are supplied with complementary pulses. So, T1 and T2 are applied with complementary pulses. Gate pulses. So, it means when T1 is on, T2 is off, when T2 is on, T1 is off. So, this is actually the output in this case. So, what we have here is the following. So, this is the zone for which T1 is on and T2 is off. That is why we call this to be T on, and for this zone T1 is off and T2 is on. So, this is the time here and this is the armature voltage VA and this is plus V and this is 0. Now, we define the duty cycle in this case is delta. So, delta here is T on by capital T. Now, what about the average armature voltage? So, from this voltage waveform we can very easily find out the average armature voltage as before by integration. So, by inspection we can say that the armature voltage here is delta into V, delta is the duty cycle, that is equal to delta into V. Now, let us plot the current waveform as well. Now, if we plot the current and voltage waveform at in the same plot, this is the voltage waveform which is a rectangular waveform with some T on and T off, and we would like to plot the current waveform as well, the armature current waveforms. So, the time axis is is the x axis, this is for the voltage, armature voltage, and this is for armature current. Now, how will the current change? Now, first of all, let us see that this is a first order circuit, and we know that say for example, t greater than 0 less than t on, we have the equation V is equal to R A I A plus L A d I A by d t, the inductance drop plus the back EMF. Now, this is the duty interval. And from t greater than t on less than capital T, we have 0. The current is freewheeling here in this case. So, it is 0 here. So, that is equal to I A R A I A plus L A d I A by d t plus E. This is the freewheeling interval. Freewheeling, or we can say energy storage interval, energy storage interval. Now, the output current or the armature current will have a different waveform. Say this can be like this, can come like this can be positive, this can be negative, both. This may not be always be positive. So, we have the armature voltage here, and this could be the armature current. Now, let us try to find out which devices are conducting for various zones. So, if we divide this into various time region, in the say for example, in the first region here the voltage is positive, but the current is negative. Let us look at the chopper circuit. Voltage is positive, but the current is negative. If the voltage is positive, either we have T 1 on or D 2 is on, but the current is negative. When the current is negative, D 2 has to be on here. So, D 2 is conducting. So, we can say that this is the interval for which D 2 is conducting. And for the second interval from this point to this point, the voltage is positive and the current is positive. When the voltage and the current both are positive, we have T 1 is taking the current. So, T 1 is a device which is carrying the current here, that is T 1. Now, for the third interval, which is this is our capital T as before, it is one time period, and this is T on. So, from T on to capital T for the third interval is this duration, where the voltage is 0, but the current is positive. The voltage is 0 means it is freewheeling or it is storing the energy, but the current is positive. When the current is positive, it means it is freewheeling. So, the freewheeling is taking place through the diode D 1. So, here D 1 is conducting the current, and for the fourth zone, which represent for which the voltage is 0, but the current is negative. When the current is negative, which means the transistor is on, it means the energy is being stored in the inductor LA for the braking operation. So, this is the region for which T 2 is on. So, this is for one cycle and the cycle repeats. So, we have 4 devices here, they are conducting for various regions, for various time zones. Now, when can we say that the average current is positive or the average current is negative? Current is reversible, voltage is always positive or 0. Now, the current, the average current depends upon the value of the applied voltage. So, the current here depends on delta V minus E by R A. So, the average current is positive if average voltage is higher than the back EMF, this for the motoring region. So, we can say that the the machine is motoring if delta V is higher than E or the average current is positive. And in this case average current is negative if delta V is less than E. Delta V is less than E, that is for regenerative braking. So, this is a motor or this is a drive which can operate in two quadrants. It can operate in motoring, it can also operate in braking, but the voltage is always positive, which means speed is positive. So, if we plot the operation in speed torque characteristic, we will say that this can operate in all these two quadrants. This is speed torque characteristic with variation of delta. This is our first quadrant and we have the second quadrant here. The speed is in the y axis and torque is in the x axis. So, the operation of this converter is both in the first quadrant and second quadrant. So, that is why this is called a two quadrant converter. So, this the first quadrant is for forward motoring, and the second quadrant is for forward regenerative braking. However, with this converter, although we are able to have both braking and motoring and braking, the speed is only in one direction, we cannot reverse the speed. We have another topology of this two quadrant converter, that is called a type B topology. That also operates in two quadrant, but the topology is little bit different. So, let us see type B two quadrant converter. Or chopper, let us say. Two quadrant chopper which is type B. Now, in type B what we have is the following. We have the transistors and the armature is connected here, and the transistor is connected in series with the armature. We have the DC supply here plus V, and here we have the diodes. So, this represents the armature of the DC machine. We have the resistance, inductance and back EMF. The current goes into this IA and the voltage here is VA with this positive and this negative. So, we can call this transistor as T1, this transistor as T2, this diode as D1 and this diode as D2. Now, we can write here that VA is equal to V if both T1 and T2 are on. When we have these two transistors on, the voltage across the armature is same as the source voltage. VA is same as capital V, and that is equal to minus V if diode D1 and D2 are on. If instead of the transistor, if the diodes are on, this is on and this is on, the voltage across the armature is minus V. So, the voltage is reversible. The voltage is reversible. So, what we conclude here, V A is reversible, V A can change. What about the current? The armature current here, armature current is always positive. It means armature current, no matter what happens, armature current cannot be reversed here. I A is only in one direction. So, this converter, if we see the operation of this converter is different from a type A converter. Here we have, let us say, voltage in the y axis V A, and the current is in the x axis, and as we have seen, in this case current is always positive, voltage can be positive or negative. So, this converter operates in these two quadrants. So, type B converter operates in quadrant 1 and quadrant 4. But however, this type B converter is not very popular for armature voltage control. This is employed in the field circuit to quickly change the current. This converter finds more application in the field circuit than in the armature circuit. Here we can change the triggering pulses, so that the current can be controlled very quickly. So, instead of having this in the armature, it is sometimes beneficial to control the current by using type B chopper in the field circuit. Now, let us see a 4 quadrant converter. Or a 4 quadrant chopper. Now, a 4 quadrant chopper consists of 2 type A DC chopper. How? Let us say we have the armature circuit like this. We have the resistance, inductance and back EMF. We use 2 type A choppers. One chopper is in one terminal, this is one type A chopper having diode here, and diode here, and then we have another type A chopper in the other terminal. Here also we have 2 diodes, one diode this side and other diode the other side. So, this is a 4 quadrant chopper, it can operate in all 4 possible quadrants. So, the input voltage is V, which is shown by maybe a battery, that is V here, and the armature current is I A, the armature voltage here is V A. Now, we call this transistor as T 1, diode was D 1, this transistor as T 2 and the diode as D 2, this transistor as T 3 and the diode as D 3, this transistor as T 4 and the diode as D 4. So, we can say that, say for example, if T 4 is on, it means this switch is permanently on and T 3 is off, this switch is permanently off. So, T 4 is on and T 3 is off, and what we do here is the following: having this off, we say that T 1 and T 2 are operated. In complementary fashion, in complementary mode. So, we we apply the triggering pulse to T1 and T2. So, in that case this is basically using this type A. So, we have one type A chopper here, we have other type A chopper here. So, in that case when we in this mode T4 is on and T3 is off, T1 and T2 are operated, we are basically using the left hand side. So, this is, we can say that this is L and this is R, the right hand side one. So, one of the type A choppers is operated. So, in that case the voltage is positive here. So, for this mode VA is always positive and IA is reversible, IA is reversible. So, when we are operating by a type A left side, VA is always positive because this can be plus V and 0, but IA can be positive or negative. So, on this, in this way we can operate in forward motoring and forward braking. So, this is for forward motoring and forward braking, because the voltage is always positive. We take the second situation. The second situation is T1 is on, T2 is on here, T2 is on and T1 is off. And what we do here, T3 and T4 are operated in complementary mode, in complementary mode. It means what we are trying to do here, we have changed our operation. Our operation is now T2 is on, so this is on, T1 is off, so this switch is off, and T3 and T4 are operated in complementary mode. So, in that case the voltage is always negative here. So, VA is negative. So, this will lead to the situation that VA is negative and IA is reversible, IA is reversible. So, when this is the situation, we operate in this case for reverse motoring, and reverse braking, So, if we plot this in a VI plane, let us say our armature voltage is VA and the average armature current is IA. So, we are plotting the operation of this 4 quadrant chopper in VA IA plane. So, for the first condition VA is positive, but IA is reversible. So, we are operating in this 2 quadrant, quadrant 1 and quadrant 4. And for the second case, this is the first case, and for the second case we are operating in negative voltage, but reversible current. Voltage is negative here and the current is reversible. So, we are operating in the third and fourth quadrant. So, we have quadrant 1, quadrant 2, quadrant 3 and quadrant 4. So, by using this 4 quadrant chopper, we are able to operate in first quadrant for positive voltage and positive current, second quadrant positive voltage, but negative current, that is forward braking. Then in the third quadrant negative voltage and negative current, the motor has reversed, it is in the reverse motoring condition, and then we have negative voltage and positive current, that is the reverse braking. So, if we see in the speed torque characteristic, this type of converter can truly make a drive operate in all possible quadrant. This is the speed torque plane, this is the forward motoring, forward braking, reverse motoring, and we have reverse braking. So, when we are using a 4 quadrant chopper, we are able to operate in all possible quadrants. It means whenever we are using this for an electric vehicle, let us say we employ a 4 quadrant chopper fed DC motor in an electric vehicle, we can go forward and brake in the forward condition. We can go in the backward direction, that is the reverse motoring. We can also brake in the backward direction. So, truly an industrial drive which requires to be a reversible drive needs a chopper like a 4 quadrant chopper. So, thus we conclude our discussion on chopper fed DC motor, it means under motoring and braking condition. We will continue in the next lecture.